taxi. Roger, 181 taxi, runway 4 left via Juliet. You'll be number 6 for the active. Approach, how much longer do you want us out here?
Continue holding 73. You are number 4 for approach.
Hurry up, I'm gonna hold out here till my gate clears. Can you pull forward at all 1606? I've got 3 planes that have to get by you for the south terminal.
Ramp 101's ready for pushback. There is a 30-minute delay at 101. I advise holding at the gate.
Air transportation brings economic prosperity. More than 22 million jobs, $1,000 billion. This was aviation's impact on gross world output in 1992. Tourism, business, shipping, jobs, wages, taxes. As long as the airplanes fly, the economy will prosper. Who has the competitive edge? Who has the potential for economic growth? Who has the most efficient air transportation system? The answers will be the same. Isn't it ironic, then, that aviation, first a contributor to economic prosperity, now threatens to take that prosperity away? Tourism, business, shipping. The demand for air service is outstripping the system's ability to deliver. More planes are purchased, more flights are added. Meanwhile, the reluctance to invest in air traffic control equipment, terminals, runways, and ground transportation continues. Inefficiency, congestion, delays. Air transportation is strangling on its own success. But the situation isn't really that serious, is it? Delays are an inconvenience, but we've learned to live with them. We know that safety will not be compromised. Eventually, the planes get through. Eventually, connections are made. Eventually, the destination is reached. How can a mere inconvenience be considered a threat to economic prosperity? A 747 idling in line for the runway burns 17 gallons of fuel a minute, 1 liter per second. Who pays? You do. Your national economy pays, and it pays far more than the price of the wasted fuel. Airlines must recover their operating costs or go out of business. Ticket prices go up. Each increase makes the decision not to fly easier to make. Business travel drops off. Tourists stay at home or go elsewhere. Hotel, restaurant, and retail industries suffer. Jobs are lost. Business opportunities are lost. Local spending is reduced. Tax revenues dwindle. Government projects and programs go unfunded. So what is the true cost of an inconvenient delay? By the year 2000, the cost of congestion and delays in Europe alone will be $6 billion a year, and growing. Delaying a 747 1 minute per hour costs the world's economy $1 million per year. And at any given moment, up to 500 in-service jetliners are sitting idle. Safety requirements and the laws of physics will put a cap on the number of airplanes that can be operated in today's system. Many terminals and airspace corridors are approaching the saturation point now. Yet nations that are willing to pour millions into projects to improve their economic and competitive positions continue to pay only lip service to improving the air transportation system, a key ingredient of the economic prosperity they hope to achieve. The irony is that even as some regions of the world are beginning to suffer the economic penalties of an inefficient air transportation system, the means to improve the system are within their grasp. Larger, more efficient satellites to relay data and voice messages will eliminate areas of poor or non-existent reception. Flight plans can be transmitted and implemented automatically, reducing the risk of navigation errors. Flight crews can be notified of changing weather conditions anytime, regardless of their current position. And by using onboard fans equipment to provide automatic surveillance and reliable communications, fans can put more airplanes on the most efficient routes by reducing aircraft spacing. FANS does not depend on undiscovered technologies. The navigation satellites launched by the US and the Russian Federation are in place and functioning. The necessary communications satellites are in place and functioning. Aircraft and ground-based systems have been certified. Inmarsat has proven the reliability and flexibility of two-way satellite-based data links on air routes around the globe. And its newest generation of satellites will enhance the accuracy of the GPS and GLONASS navigational satellites even more. All new generation wide-bodied jetliners are factory equipped with satellite-based communication, navigation, and surveillance capabilities. Most business and general aviation aircraft are being fitted with FANS-compatible equipment. And FANS routes are being flown today in the South Pacific, with plans for expansion throughout the Pacific and into Southern Asia, China, and the Russian Federation. Given the logic behind the system and the economic growth it guarantees, doesn't it make sense for industry, governments, and operators to work together to implement FANS as soon as possible? Long-term economic rewards require across-the-board commitments. Putting more planes in the air does little good if they have nowhere to land. Runway, taxiway, and terminal capacities must be enhanced. And while the airplanes provide pathways to prosperity, it's the passengers that make it happen. Automation can increase the flow of passengers through check-in, baggage handling, customs, and immigration. But the journey does not end at the terminal doors. From widening a highway to installing a direct rail link, any investment aimed at making your airports more accessible will make them more functional and more profitable. Creating a high-capacity global air transportation system will take cooperation. No one nation can undertake it alone. It will be costly. It may involve political risk as national and cultural differences are resolved. But waiting for someone else to take the first step, or refusing even to acknowledge the need, will be far more costly. Where do you want to be in 10 years? You can be in the best possible position to participate in the global marketplace, or you can be bypassed. You can help your tourist industry grow, or you can watch the tourists go elsewhere. You can help attract international business, or you can allow inconvenience and delays to drive it away. The concept is simple: to move people and products from one point to another as quickly and efficiently as possible. The need is real. The benefits are real. Each step toward implementation is a step toward long-term economic prosperity. How fast and how far you go is up to you.
Business and commercial aviation is on the threshold of a revolution, a tiltrotor revolution. Thanks to breakthroughs in aeronautical and manufacturing technology, Bell Helicopter Textron and Boeing may soon develop a business aircraft that gives commercial aviation the combined advantages of a helicopter and fixed-wing turboprop. Bell and Boeing, partners in development of the V-22 Osprey military aircraft, have proven the high value of tiltrotors through decades of research and development. The XV-15, a tiltrotor concept demonstrator built for NASA, has more than 15 years of successful flight experience. Tiltrotors feature the vertical takeoff, landing, and hover advantages of helicopters with the speed and range of turboprop aircraft typically used in business aviation today. By tilting the rotors, a tiltrotor aircraft provides quick, smooth, and stable transition from helicopter to fixed-wing flight. This means business travelers can board their aircraft at the company heliport, lift off, transition to airplane flight, and land vertically at their destination with no plane changes, no waiting at airports, and no long taxi rides to final destinations. This new combination means less overall travel time between true origins and destinations, fewer delays from air traffic congestion at airports far removed from business destinations, and the added convenience of flights directly to business locales. Tiltrotor technology allows development of aircraft tailored to business aviation needs. Proposed designs will enable up to 9 passengers to travel non-stop in pressurized comfort. In airplane mode, the tiltrotor can cruise 270 knots at 25,000 feet as far as 800 nautical miles. Applications include corporate business travel, resource development, and air medical service. As intermodal transportation systems develop in the 21st century, tiltrotors will add to the flexibility and efficiency business aviation demands. With tiltrotors, air travel can increase without reliance on already overcrowded airports and overbooked commercial flight schedules. And for business aviation, convenient landing locations and other infrastructure are often already in place, enabling this new transport era to begin quickly with immediate benefits. Business aviation will increase productivity by moving passengers more quickly than ever, eliminating the need for complicated travel plans. And that means higher business aviation utilization rates at lower cost per passenger mile, a winning formula for flight departments and their customers. In sum, Bell-Boeing business aviation tiltrotor aircraft can offer superior service in the 21st century, providing efficient, time-saving travel to meet broad aviation needs. The revolution in business aviation is coming. It's time to get on board.
In nature, man discovered an efficient solution to realize his dream of flight, the wing. Over time, he has turned, twisted, flapped, and spun the shape, and man has flown, hovered, and soared. From this single desire, man's pathways to flight have diverged. We learned to use a fixed wing on an airplane. This vehicle can cover medium to long distances in fast forward flight. But airplanes require runways. In a different way, a rotary wing can be utilized to provide both lift and propulsion. The helicopter. This aircraft is able to operate without the aid of prepared runways, but its forward speed and range have always been limited. Some visionaries dreamed of a convergence of these two paths. One aircraft that combines the advantages of both fixed-wing and rotary-wing flight. An air vehicle that makes possible a new dimension of flight, a freedom of flight never before available. Though many concepts were studied, the idea of an aircraft with tilting rotors emerged as the most promising. The United States military saw the potential of tilt-rotor aircraft as early as 1950, and the Bell XV-3 was the result. This first functional tilt-rotor converted between helicopter and airplane flight modes more than 100 times, and showed for the first time the promise of tilt-rotor technology. By the mid-1970s, a modern turbine-powered tilt-rotor was developed. The XV-15 quickly proved to be stable and efficient. It established many benchmarks for tilt-rotor aircraft, including reaching a true airspeed of more than 300 knots in level flight, more than twice the cruising speed of a conventional helicopter. The ability to convert between hovering and high-speed cruise flight was finally within America's technology grasp. At the same time, the U.S. government was looking for a single aircraft that could satisfy the vertical lift needs of all 4 military services. And tilt-rotor technology was the logical choice. 2 world-class companies, Bell Helicopter and Boeing, combined their expertise to win this program. Through years of testing, design, and modification, tilt-rotor technology came of age. Thanks to visionary bipartisan support from many U.S. government leaders, a production contract was awarded for the world's first operational tilt-rotor, the V-22 Osprey. This unique American product will soon be providing the United States military services with the diverse multi-mission capabilities they require. But Bell and Boeing had long believed that this dual-use technology could also be of service in civilian aviation. Imagine a single aircraft that can perform both helicopter and airplane missions at a competitive cost. Both companies committed themselves to making that dream become a reality, converting the way man flies. A new commercial tilt-rotor takes the technologies proven through the years of military development and now brings them into the civil aviation world in a reliable and flexible aircraft. Imagine one vehicle in place of 2 that are currently required for search and rescue missions. A single tilt-rotor covering up to 5 times more area than a single helicopter. For busy travelers, a tilt-rotor will be one of the quickest forms of office-to-office transportation for travel between 50 and 500 miles. With available vertiports, no typical combination of car, helicopter, private jet, or airline can transport people or cargo in less time over these common distances. Offshore oil workers will enjoy non-stop trips to platforms in half the time. And tilt-rotors will bring remote energy fields closer to existing bases at a reduced cost. But this is just the beginning of what tilt-rotor technology offers to civilian aviation. Combine the benefits of helicopter and airplane flight into one aircraft. Add flexibility, time savings, and lower costs, and witness a milestone in aviation history. America's tilt-rotor technology, providing a new way for the world to fly into the next millennium.